Let's continue on with our introduction on statistics and talk about measures of spread. Our two most common measures of spread are range and standard deviation. Range is simply the difference between the minimum and maximum values. It's a basic subtraction. While standard deviation is the average distance between the mean and a value in the data set. So we're basically calculating the amount that every single data point deviates from the mean. The larger the standard deviation, the more spread out the data is. The smaller the standard deviation, the closer together the data values are clumped together. So let's look at range. Let's take a look at examples A, E, and F from above, and we want to find the range of each of those data sets. So for example A that we had above, A has a minimum value of 2 and a maximum value of 10, so we just subtract 10 minus 2 and we get a range of 8. For data set E, when we look above, okay, we're looking at our actual data values. We have a minimum value of 0 and a maximum value of 3. So 3 minus 0 equals 3. And then let's take a look at F. We're going to be looking at the quantitative data, the numerical values, where we have a minimum value of 2 and a maximum value of 15. So 15 minus 2 equals 13. So we have the three ranges for those data sets. Now when we're comparing standard deviation, again, we just want to look at how spread out is the data. So here we have two dot plots with some different data sets shown. The first data set has two values at 5, one value at 10, 2 at 15. And this data set has 1 at 0, 1 at 5, 1 at 10, 1 at 15, and 1 at 20. Well, in order to determine which one has a greater standard deviation, we want to see which one is more spread out in the data. And if we look at the second chart here, the data is more spread out. Therefore, it has a greater standard deviation. Now let's take a minute to look at how we can compare spread. The table to the right shows the amount of time Jasmine and Pablo spent practicing guitar. Calculate the range for each person. And if each person has a mean practice time of 45 minutes, who has a larger standard deviation and why? Range is pretty easy to calculate. It's just a simple subtraction. So the SAT will often or occasionally have you calculate these values to compare them. However, standard deviation calculations are much more involved and a much longer process unless you have a calculator specifically designed for calculating standard deviation. And even then, it's not fast. It still requires you to input every value to figure out what the standard deviation is. And so typically when we're dealing with questions on standard deviation, we need to just look at the data set and kind of get an idea for the amount of spread within the data in order to determine which one has a larger or smaller standard deviation. So range is pretty straightforward. If we look at the range for Jasmine, we just take her longest practice time, which is 60 minutes, and subtract her shortest practice time, which is 30 minutes, and Jasmine has a range of 30 minutes. If we look at the range for Pablo, we find his longest practice time is an hour and a half, and his shortest practice time is 0. So when we find that difference, Pablo has a larger range of 120 minutes. When we want to figure out who has a larger standard deviation, well, we're comparing that they both have the same mean of 45. So we want to figure out which data values deviate more from 45. Well, 30 minutes only deviates by about 15 minutes from 45. 45 doesn't deviate at all. 30 is, again, 15 minutes. 45 is none, none. 15 minutes higher, 15 minutes higher. So all of Jasmine's times deviate between 0 and 15 minutes. When we look at Pablo's times, well, 30 is 15 minutes from the mean of 45, but 0 is 45 minutes away. 0 minutes at 45, 15-minute deviation, another 45-minute deviation. If you practice for an hour and a half, that is 75 minutes of deviation. And then, if you practice for 2 hours, that's 75 minutes deviation. And then for an hour and a half, we're looking at 45 minutes of deviation. So Pablo deviates anywhere 0 one time, then he deviates 15 minutes from the mean twice. He deviates 45 minutes from the mean 3 times, and once he even deviates 75 minutes from the mean. And so we can see visually that Pablo's data deviates much more from the mean value of 45. Therefore, Pablo's standard deviation is larger. Pablo's standard deviation is larger because his time vary much more. Now let's take a look at some other ways of how we can use spread to answer and evaluate different questions. So Christine and Lance are taking the same class. The table shows their test scores for the class. Which of the following statements about their test scores is true? Christine has a greater range of test scores than Lance does. Well, we could calculate that pretty quickly. Christine's lowest test value is a 93. Her highest test value is a 95. So Christine's range is 5. The difference between those values is 5. Lance's lowest test score is an 88 and his highest is 100. That gives Lance a range of 12. Well, that statement's not true because Christine's is more closely clumped together. Her range is less. Christine has a greater standard deviation of test scores. Again, Christine's data values are much more closely related together. We could have a very small range, so they're all closely clumped. Lance has more spread, so that's not true either. Christine and Lance have the same mean test score. Okay? Well, we could test that, but that one's going to take a little bit more time. Let's check the next one first and see if that makes sense either. Christine and Lance have the same median test score. Well, if we take their values and say, okay, Christine's lowest score is 93, then a 94, 95, 95, and 98. Okay, we see Christine is much more consistent. Lance is 88, and then 95, 96, 96, and 100. Well, here's their median test scores, and those aren't the same. So we know that that one is wrong. And the correct answer is C. Christine and Lance have the same mean test score. And we could verify this by calculating the mean, and we end up getting 95 for both of them. They both have a mean of 95. The minimum value of a data set consists of 15 positive integers is 29. So the minimum value of these 15 data points is the number 29. Okay, so I have 29, and then I have a bunch of other data points above it. A new data set containing of 16 positive integers is created by including 22 in the original data set. So we take this data set and we're adding in another data point, 22. And then we have 29, and then all the same data points as before. Which of the following measures must be 7 greater for the new data set than the original data set? So we have to think about the mean, the median, the range, the standard deviation. Which one is going to be larger by a value of 7 by including this lower number? Well, whenever we add in another value for the mean is going to shift up or down in the direction of the new data point. Okay, well, since our new data point was added at the bottom, our mean is going to decrease. Okay, and so because the mean is decreasing, it can't be 7 greater. So we know that that's not going to be the case. Well, then we think about the median. The median is going to have a similar effect. It's going to shift in the direction of the new data point, not as much as the mean, but because we're adding a new data point down lower, our median will also shift down. And so we know that the median is not the correct answer either. Well, what about the range? Well, the range, by adding in this data point, well, this minimum value is now 7 further away from the maximum value. Whatever our maximum is, our range is now 7 units further, 7 units further from the maximum compared to the previous minimum value. And so the range is the only one that makes sense here because we see that our minimum was decreased by 7, which means our range is going to increase by 7. There's more spread. Standard deviation, we wouldn't really be able to answer that question because we don't have enough information to really look at the standard deviation. However, it's unlikely that adding one data value that's only 7 units away from the previous minimum is going to affect the standard deviation that much. We would have to add a bunch of data points lower than that in order, or actually above it, either below or above it, to increase the standard deviation that much. So the standard deviation just doesn't make sense. So these two examples are more along the lines of how we would use our measures of center and spread to analyze the trends that are within various data sets.